Hello. So we're going to be doing a question from section 4.3, how derivatives affect the shape of a graph. So we're going to look at question 34. The graph of the function y equals f of x is shown, and this is the graph of the function y equals f of x. At which points are the following true? So part A, dy by dx, the first derivative is positive and the second derivative is also positive. So in order to answer this question, we first need to be able to understand the relationship between the sign of the derivative and the shape of the graph. So what does it actually mean when the first derivative is positive? How does that relate to the shape of the graph? So we're going to do some example graphs here to look at how the shape of the graph is impacted by the first derivative sign. There we go. So pretty much first derivative is the slope of the function, right? So we're going to take the instantaneous slope at various points on this function. There we go. So the slope is positive and the function is increasing. So the relationship between the first derivative and the graph of the function is that when the first derivative is positive, the function is going to be increasing. Similarly here, we're going to take the first derivative at various points. The slope is negative. The function is decreasing. So the relationship here is that when the first derivative is negative, the function is decreasing. So now we understand how to relate the first derivative to the graph. So we can start on the first part of the question. So A wants us to find a point at which the first derivative is positive. So we're looking for a point at which the first derivative is positive and the function is increasing. So that eliminates A. B is an option, C is an option. It eliminates E because E is decreasing. It also eliminates D. And the reason it eliminates D is because D is a point at which the slope is neither increasing nor decreasing, because the slope is just 0. The slope is just 0. So it's neither positive nor negative first derivative because it's not increasing or decreasing. So now we have the option of C or B or both of them. But we have to first understand what the second derivative being positive, what that impact will be on the graph of the function. So if the second derivative is positive, what will that look like? I'm going to do some example graphs. So we're just going to look at increasing function since we already figured out that it has to be increasing. So when the function is increasing, I'm going to look at the second derivative, which second derivative is pretty much the slope of the slope. So we're going to take the instantaneous slope at various points on this graph and just look at how the slope changes. The slope of the slope. As you can see here, although the function is increasing over the entire domain for which I have drawn it, the values of the slope are getting smaller and smaller positive numbers. So although the slope is positive and the function is increasing, the slope of the slope is going to be negative. So the second derivative here is negative, because although the slope is still positive, as we move along and the x values increase, it becomes a smaller and smaller positive number. It becomes less and less positive, essentially. So as you can see, the shape of this one is concave down. So that's the relationship between the shape of the graph and the second derivative. When the second derivative is negative, the graph is going to be concave down. Similarly, looking here, we're going to again take the instantaneous slope at various points. And as you can see, the slope of the slope. So the slope is always positive. This function is always increasing over its domain. It's always increasing. However, you can see here that as the x values increase, the slope is getting steeper and steeper. The value of the slope is getting larger and larger. So this is a positive second derivative because the slope of the slope is increasing. So positive slope of the slope, positive second derivative, means concave up. As you can see, this is concave up. So that's the relationship between the second derivative and the shape of the graph. So now we know that when it's asking for a second derivative that it's positive, it's asking for this, for the graph to be concave up. So now looking at C and B, we know that B is concave up, so B works. C does not work though because it's concave down. So C does not work. The answer to part A is going to be point B and only point B. Now moving on to the next one, part B. When the first derivative and the second derivative are both negative. So as we saw up here, when the first derivative is negative, that means that the function is decreasing. So we're going to just look at points on the graph where the first derivative is decreasing. So A is an option, B is not an option, it's increasing, C is not an option, it's increasing, D again is not an option because in this situation it's not increasing or decreasing, and E is also an option. Now we're going to look at the concavity by studying the second derivative. So the second derivative is negative. As we see here, when the second derivative is negative, that means the function should be concave down. So in the case of B, B is not even an option. In the case of A, it's concave up, so it can't be A. Then we look at E. E is concave down, so E works. It satisfies these conditions. So the answer to point B is point E and only point E. Now the last part, part C. We're looking for a point at which the first derivative is negative, but the second derivative is positive. So when we know that when it says the first derivative is negative, just as we saw here, that means that the slope has to be negative. The function has to be decreasing. So A becomes an option, B is not, C is not, and D is not, but E is an option. Now we're looking at when the second derivative is positive. So if the second derivative is positive, as we saw here, the function should be concave up. I'm going to look for, of our options, which one is concave up. A is concave up, so A works. E is concave down, so E does not work. So the answer to part C is point A and only point A. And that's how you solve this question.